David, I hate to tell you, but you've lost the terminology argument.
I know.
People are going to use generative design.
The mob has spoken.
The mob has spoken, and it's going to be used until we run that marketing ship into the ground. Why don't we go around the table here? I'm Nate.
Kristen.
And I'm Dave.
We are members of Proving Ground, and we are ready to talk a little bit about technology and doing some technology reviews. This is a new format for us, so we'll probably be ironing out a lot of bugs along the way. Hopefully the format improves over time, but the big philosophy of this is that we're trying to promote good critical discussion about technology and what it means to be operating in an industry that's undergoing rather significant changes in construction and architecture. And why don't we start with a fun topic, and we'll see if we have to edit it out a little bit later. But the April Fool's fallout, I thought, was pretty interesting. We got a really good response to the videos. I had people contacting me to ask if we were serious.
That's exactly what you want out of an April Fool's.
And I thought it was obvious that it was a joke, but some people actually reached out and were like, "Are you really going to do unboxing videos?" And
unboxing what?
Yeah. And the unboxing video I thought was the most absurd portion of the whole thing.
Well, that
I'm
was
just
like
like
it
shaking.
if it wasn't clear by then that it was a joke,
yeah,
literally chucking everything onto the table.
Right. I thought it was a good chance, obviously, for us to try out this equipment and see if this was even worth anything.
Just play around.
And now we're trying the real thing, which is fun. And so there's two segments that I'd like to talk about. One is just sort of recent AEC tech news. So there's obviously new stuff every day happening that we can just kind of riff on and go back and forth on new developments that we're seeing. And then the other segment today will be about generative design, the kind of infamous term that seems to be working its way through just about every discussion that we're encountering now when it comes to computation or BIM. So everyone's looking at generative design as a thing.
Self-replicating.
The self-replicating. They're they're not kidding. They're generating thousands of something.
Generating a lot of buzz about generative design.
Right. And they're generating buzz. So the first thing I thought we'd do is just talk about some tech news here. Rhino.Inside.
Rhino.Inside.
That's just now starting to kind of come to light as like an interesting approach to how Rhino situates itself in the workflow. For those that are just tuning in, Rhino.Inside is essentially kind of a new API in a way where if you're in an application like Revit, you can reference Rhino directly and start doing things from within this other environment. So you're literally sticking Rhino inside of something else.
Yeah, Rhino, McNeel's made it so that Rhino is, obviously it's capable of being a standalone application, but this makes Rhino a plugin for any other application that can host a plugin.
Which speaks to how lightweight it is as far as something that can sit inside of something else and still run without completely bogging it down. It's
totally
amazing.
Yeah, it's really very, very clever. With the benefit being that then you can use the Rhino API adjacent to the API of the host program, so that they share a programming environment, which is kind of like the dream of interop, is to be able to have two software platforms fully access each other, not some kind of stripped down thing. Yeah. Like as good as OpenNerbs is, it's still stripped down.
It's stripped down.
So
and it avoids, it sort of like bypasses the entire need for kind of a file format discussion. It's about API to API connectivity.
Totally.
And it's probably one of the shrewdest moves I've seen the McNeel folks make. I mean, the idea that I can just kind of, Rhino is almost like for lack of a better term, a virus that can start infecting all of these.
I should call it Operation Trojan Horse.
Right. It's like a well, it's the tool that everyone wants to use. Rhino is just an amazing modeler. And I think it's always been a thing where, at least for me, Rhino being one of my favorite tools, where you're inside of another modeling environment like the Revit family editor, and wanting desperately to have your toolkit back. You know, and I'm sure the Autodesk folks that might be tuning in are probably going to do a bit of a face palm where you hear like, well, you know, Rhino can do it. Why can't yours? And now
all the time.
And now it can. Now it can. Now.
Right. Well, I mean, the bringing the two together really plays on the strengths of both. You know, Rhino's really good at 3D geometry, especially non-rectilinear geometry, whereas Revit is really good at producing document set, which is what it was, I believe, initially made for. So this kind of brings those two parts of the AEC industry together in a really interesting way.
The challenge is, and this is something that we're very familiar with, is now that you have them together, how do you actually transfer information between them in a way that's really effective? And this is where a lot of the legwork remains. The thing that's impressed me about McNeel's approach is that, so first they really have developed that framework, and they have other frameworks that are similar to this, like Rhino Compute. Like they're doing as much as they can to make Rhino a distributed geometry solver, basically, an authoring tool, which is really fantastic. But now what they've done is they've also put, so initially it was developing the framework, but now they're really putting some development into implementation as well. So I mean, the stuff that Louis has been sharing, this is Louis Fragata, he works with McNeel, and he's been sharing some things on his Twitter account, which show how Rhino.Inside is now being integrated with Revit. And they have some developers there that are really just going in and starting to do things like family authoring and geometry preview, you know, so really taking advantage of the lightweight geometry preview capabilities. So it's, I mean, there's some real serious development happening there.
Right.
And then there's the huge elephant in the room with it, which is Grasshopper. You know, and just if you have Grasshopper sitting inside of Revit, and it has the ability to directly author native Revit families with the advantage of Rhino's geometry kernel, you know, that
is it a Dynamo killer?
Is it a Dynamo killer?
Yeah, I mean, and if we look about Dynamo, I think introduced a lot of really good things into the conversation. I mean, people need to interface with building information models. People need to be able to develop systems with their building information models, and Dynamo became the answer to that, using a very similar graphical language that Grasshopper had. You know, everyone likes the node wire model for
directed acyclic graph. That's the deal.
Exactly, and Dynamo is the answer to that, and I think in some ways it was also the result of the community asking, can there be a Grasshopper for Revit? And you know, that became the model for the program, and now we have literally Grasshopper for Revit as a possibility, and obviously I think it has a ways to go before it captures all of the possibilities that Dynamo currently is able to do, but I think it shows real potential.
There's a lot of things that have been developed for Grasshopper open source that are available out there, that the toolkit is just so vast that to try to replicate that in Dynamo, the man hours that would take is just insane.
Yeah, there's so much embedded intelligence in the Grasshopper community, and there's quite a bit in the Dynamo community too. But to your point, I mean, there's some really sophisticated packages that are out there, and more than anything else, I think it's just the speed of the geometry kernel in Rhino, and just how efficient it is, and the ability, the things that I think that are really going to set it apart are its potential, its ability to handle intersections, really good intersections, meshes, and
that's like a sore spot right now in the Dynamo world and Revit in general. I mean, it's one of the things that we've published white papers on. Is this positioning of meshes within the building information modeling language and delivery systems. The use of meshes in Rhino is quite good, and the ability to kind of customize ways of dealing with them is very strong, which is another interoperability opportunity for having these worlds to more closely connected.
Totally.
But speaking of Grasshopper and catching up to Grasshopper, we have another piece of tech that's hit the scene in the form of xGenerative Design, XGen for short, that is being introduced by Dassault as part of their CATIA platform and 3D experience. It's interesting that I'm kind of surprised it took them this long, to be honest. Like it's kind of been an obvious thing that a lot of technology companies in the AE space have been looking to get to. Dassault has not historically been very focused on AE, so that could be part of the reason that they're just now getting to it in their framework, because they are making a very obvious play to get into the architecture and construction space. But it is interesting that they see kind of this need for a Grasshopper clone in their platform, which already has a very well-established language for parametric trees and relationships. What do you make of sort of this whole idea of Grasshopper cloning in the general sense? I mean, we have Grasshopper, which really kind of accelerated this idea of the node kind of relationship. You then have Dynamo, which is the next kind of most popular tool. And then you have Marionette, which was introduced for Vectorworks. You have a node model for Blender.
Yeah, I mean, it's interesting actually to go on that side of things. I mean, you have also, I mean, both Blender and Houdini have like super powerful node modeling capabilities.
Yeah.
That are really efficient at going back and forth from code to, the node to code thing where you can write code and convert it.
Yep.
All the dependency graphs that those software platforms have is really incredibly sophisticated. I think that will, and in some ways, those are probably closer diagrammatically to Dassault's solution, because it is a dependency tree. I mean, it is a feature-based modeler as opposed to like Rhino, which is total freeform. So
right.
There's any constraint that you make, you have to impose through something like Kangaroo or whatever. So in some ways, I think it's closer to those engines, just because each thing it is kind of parametric in that traditional way.
From a user's perspective, it makes sense if you're reaching out to users of these various different platforms and trying to reach them where they are, meet them where they are, with some kind of a bridge between being a true just interface user and doing some coding with the platform. It makes sense to meet them at whichever platform they already are in.
Totally.
And up until recently, it's been that you have to create something specific to that platform. That's where the Rhino.Inside thing, coming back to that, is really interesting to me, because then you can really tie them all together and bring those interfaces together. And
yeah, comparing the two that we're talking about, a lingering question that's been in my mind about this whole computational design conversation is the conversation becoming too stagnant in terms of like user interface? It kind of seems like there's been a lot of copying of interface design and certain conventions. I think Grasshopper, while there has been sort of a history of those types of interfaces, really brought it to the mainstream for architects. And now you have other companies trying to catch up with that idea and introduce their own version of it. But the concern that I have is it's been close to 10 years, and I'm kind of curious to know, is there another way of representing parametric models in a way that we haven't seen before, or are we kind of saying, okay, no, the node
right
wire
this is the way to go,
is the way that we're going to do it? And is it by the fact that it is the best, or is it because that
it's what we're used to?
What we're used to.
It feels in this way that McNeel is consistently a step ahead. I mean, Grasshopper first emerged in like 2007, and there had it's interesting because Grasshopper is what everybody talks about, but generative components.
Right. I was a GC user. Were you a GC user?
Absolutely. I used GC. I used GC because I had to in a studio. but I totally got into it, and it
was a lot of fun.
Really good, and it also had a really good interface where you could also get in and code as well, so you could actually go in and modify the nodes in a script-based environment. No, I mean, it's super powerful. It's funny, Bentley kind of gets a raw deal, I feel like, because they've got some really amazing tools that don't get too used.
Well,
GC
was an important step. We can't forget that it was an important step in how architectural design met up with parametric modeling in a way that made more sense than other models, and it made it affordable to the firms that had MicroStation and that whole platform. When I was at MBBJ, we were one of the few at the time that was very much on MicroStation, and so generative design became a very interesting component to the design workflow there.
Generative components.
Generative components.
Yeah.
No, I say generative design. There's so much generative.
It's everywhere.
And we'll get right to that here in a second.
But I think that, just going back, I think that the McNeel has had it right in a sense that, so 2007 was explicit history, and it was kind of, Rutten comes out with that, and they push it. But almost immediately, it was made open in the sense that anyone could develop for it. And they completely created it as an open community and a perpetual beta open community. So the sense was it's a giant sandbox that anyone can play in. So if you can code, you can come and you can write stuff and you can make it here. And they did that first, and they did that fast, and that created this community that has made it hard for anybody else to really get that market share. I mean, Dynamo is there because it has to be, right? If you're doing Revit, you need Dynamo at this point. I mean, obviously now maybe you don't as much in the future with Rhino.Inside. But the thing the thing that I'm most skeptical about Dassault's solution is that it is part of their sort of impenetrable ecosystem of tools, which are notorious for really just liking to work with themselves. And it's fair enough in a way. I mean, it is like the Maserati of tools. I mean, it is super high end. I mean, you can detail like crazy.
You can do amazing stuff with that platform.
Absolutely. But the reason why Revit works so well, to Kristen, your point, is just that it draws really well. Like, it's great at creating drawing sets. I mean, it's really powerful, and you can represent things in a way that, it's another conversation, whether it's good or bad. Architects represent things. And I'm not seeing that in the Dassault solution. I'm also not seeing it being open to letting people make their own kind of add-ons to it. It's sort of it's hermetically sealed in a way. It's like,
especially
this
not
is
in
our tool set.
Especially not in the way that McNeel is approaching the idea of APIs and interoperability and their connections. I always feel weird constantly gushing about McNeel, but it's true. They're doing a lot of things that at least are resonating with me as a design technology person. I think the other side of this as well is expense. CATIA,
for sure.
CATIA is not a cheap platform. And I think Revit is, when it comes to like licensing models, and people gripe about price of software all the time. I think if you didn't have to pay for software ever again, I don't think anyone would.
No one would complain.
Right. Yeah. So it's always a conversation about price. But Autodesk is very good at pricing their software to appeal to architects and engineers and folks in the construction industry.
Yeah,
and
you have to balance having a 1 or 2 person shop and hundreds or thousands of people, and figuring out where that price point needs to be, where a small shop can actually use it and the adoption becomes more industry wide. That's the thing with AEC, is that there aren't very many firms, architecture firms, in the middle. They're either really huge or really small.
Right.
There's a statistic that 60% of both architecture firms and contractors in the United States are 20 people or fewer.
Right.
So it's the lifeblood of construction are these sort of smaller shops, and that makes it a very different paradigm than, say, manufacturing. And aerospace and these other companies that I think Dassault has historically served, and served very well. So the question then becomes, how do you take an industry like construction, which is very different in terms of just its general business setup, and make something like an architectural solution viable.
Right.
And I think we could spend an entire podcast just talking about the risk adverse nature and the slow to move nature of an industry like construction.
I hope we do at some point.
Yeah.
One potential I did see with the XGen is design to manufacturing. So
Yeah.
if
Absolutely.
it's
As an
if it's
end-to-end.
possible, if it's possible to parallel something that's more early design, like if you can do the same things in Grasshopper and then do those things in XGen and send that to a CATIA user who is a manufacturer, there's a potential there.
That's what they're going for.
Yeah,
I mean, that's
because
really
it's
what they're pushing.
It's a web-based.
They
So
want-
you could have a web-based, send this to the architect and say, give me the geometry as a way of bridging towards what we've been somewhat kicking around or talking about are the ideas of do we really need to always represent in 2D?
Right.
Absolutely.
Or can we find a way?
Well,
to move beyond
it's a
that?
huge inefficiency. I mean,
Yeah.
this is again another conversation, but it's an important one, which is, you know, how much is construction documentation? How much of a project resources go into that, and how many of those documents are really useful for manufacturing, for installation? I mean, it's so much of it is about risk adversity and about controlling liability, but there's a huge amount of waste in producing representations that ultimately aren't making the thing.
Right.
You know, and if you can go direct to fabrication, then you can cut out all of this wasted resource time. You know, I mean, you can focus on other things, and you can actually, and the designer as well has more control. I mean, right now everybody creates something, but then they send it to someone else to really model.
Right.
You know, I'm making the model, but it's not the real model. The real model is actually being made by the facade sub. You know, I mean, it's all being made elsewhere.
Right.
Ultimately, the 2D documentation is a communication tool. You're communicating with other designers, other people in the design team, other people in the code review team, and the building permit team, and the contractors, and all of that it needs to communicate with all of those people, but it doesn't have to necessarily be on paper.
I think
Totally.
There's another sort of side to this that I don't know is talked about as much, because we can talk quite a bit about and at length about this sort of the wasteful nature of drawing production as it relates to the construction of buildings. If the building is the end goal, then we should be employing any means necessary to make sure that end product is the best it can be, and also delivered as quickly and efficiently as possible. But there is an ingrained part of this when it comes to the culture of architecture. Architects take drawings very seriously. It's very much a part of the architecture education. You learn to appreciate a really good drawing. People talk about the poetics of drawing.
Oh yeah, of course.
And I've encountered in the context of a lot of our strategies that we do, I've encountered architects when we talk about model-based delivery and how it relates to the construction process, get anxiety about the idea that, and they'll say this as much, we don't deliver buildings, we deliver drawings. And they take that part of it very seriously, and it's very much, especially in I would say design-centric firms, it's taken very seriously as a medium, and so there's that kind of, it's a cultural shift in many ways.
It would be a massive cultural shift.
Yeah,
contractual. I mean, and that's, I mean, I
yeah,
think
and that's not even touching the contractual side.
Yeah, the barriers to entry are many. I mean, you have, obviously contracts. It's all about liability. And approvals, honestly, as well. I mean, you have municipalities that they review drawings. They don't review models. They don't have that ability to test for viability there.
Yeah.
But if they have a drawing that they can review, so I mean, there's so much entrenchment that's going to need to be overcome. But I mean, that's
just acknowledging that's not necessarily the only way to do it is hard for a lot of the industry.
Yeah.
So it's an interesting thing to explore. I think it'll be something we'll be talking about for a long time.
Right.
For sure. I mean, I think, and the more examples of buildings that are realized through that kind of process, it will result in greater adoption.
Yeah.
Right.
And for sure, we've all been involved in projects that had not all, but substantial portions were basically built from model, and sometimes it's necessary, you know, and I think a movement in that direction is you know, I personally what I would advocate for. You know, I think that you know, fetishizing drawings isn't, I mean, it's not like drawings are ever going to go away, and certainly you can continue to make all of your pretty representations.
Yeah.
You know, but it's an interesting question.
Yeah. I mean, it is a very interesting question, which, you know, and when we talk about cultural shifts and how technology plays a role in it, I imagine the people that are looking at just the introduction of BIM skeptically still, as like, and the idea of model-based production and modeling first and foremost the building, and thinking about drawings as output. I look at that sort of skepticism that still exists, and still exists quite a bit. Even we're almost 19 years into.
It's crazy.
Revit. I know someone on our social media is going to fact check me on this. Well, actually, it's only 15 years, or something like that.
You got to get something in there for the actually.
So I will post I will actually do my research and make sure it ends up in like the edit here that shows actually, Nate, it's X number of years to really circumvent that. But I look at that, and I then like, okay, well, what is that person going to say when you then say, you know what, we're going to have a computer create 1,000 options on using an algorithm, and you're going to select the best one.
So wait, you're jumping into generative
design.
I'm
jumping into generative
magic.
design now.
Yeah.
I'm jumping in to our main discussion. The main discussion for all the viewers. Generative what? Generative what? So let's get into some context here. So I look at generative, like everyone's using generative, like that term. We just mentioned just rolls off the tongue. We looked at Dassault's thing is called xGenerative Design. They've actually adopted it as the name of their one of their AE products. And then you look at a lot of the stuff that Autodesk is doing presently with generative design and kind of how they're branding certain things. We first saw Project Dreamcatcher, which is like their one of their early tools for rapid iteration, optioneering, and optimization. Project Fractal then became like another kind of version of this, and now they're on Refinery. And now they're really promoting it. They've created generative design labs in certain cities like Chicago. That's been another like marketing push. And, you know, it's actually been one of those things where I've kind of looked at this conversation and wondered, wait a minute, if this is optioneering and optimization, where does the generative part come in? To me, like I remember
we've all been wondering,
right? Yeah, and I think it's sort of a part of where we come from is like we have a very high BS detector, I think, as a group at Proving Ground, and we look at like the way that certain things are termed, and we're like, well, actually, generative means something quite different when you look at the historical context of computing, when you look at what it is meant in the world of art. And then now how it's being applied and appropriated for certain forms of technological marketing. And then the back end of the technology is using things like evolutionary solvers and optimization routines as like the main driver, which to me I've never really associated with generative as a term.
Absolutely.
And so there's some context there. So Dave, you've put out a terminology paper recently that draws from your PhD. I did some trolling on Twitter. I sometimes feel like a jerk doing this, but it was too much. It was too much for me to handle. I saw a post, and the post was, I've generated 1,000 options of this building, and very much relating to the sort of this fashionable thing that we can generate thousands of options from using generative design techniques. At which point I was kind of critical of this and thinking like, why are we generating thousands of options of something? Or the clients that procure buildings get confused if you present them with 3 options. And do architects and designers, is it really a goal for them to want to generate 1,000 options, as opposed to using other means to arriving at a solution? And I certainly think this stuff has its place, optimization and solving really hard, complex problems for sure. But
it's a question
I feel like
where does the curation happen? Do you want the computer to just spit out a bunch of things and you throw 99 out of 100 away immediately because you have a human knowledge that design isn't going to work? Or are you filtering as you go when you're designing manually and you're throwing out a bunch of options without even realizing it?
I think the emergence of this, of generative design, I think that's like as a designer, those are the questions that we have. But I think that it's in some ways the tool as these, it's a double-edged sword, the availability of computation. Voronoi is the perfect example. The ubiquity of Voronoi and like the fact that, it's now a joke, it's now a punchline as if it's Voronoi, that it's a joke. But, back in the early part of the 2000s, creating an algorithm that could actually compute Voronoi represented a real achievement.
It was sticking on a facade, using it as an urban plan, using all these things.
Yeah, that was like an achievement of implementation. And all these, Galapagos, the sort of original evolutionary solver for a design interface,
in a mainstream design interface that was really easily implemented.
Totally. And I think that once a certain kind of type of architectural designer that's really interested in parametric design and computation and these kinds of explorations got their hands on these things, that's when a lot of this started to come. It was and you see it all the time. This is another issue with machine learning. There's the solution in search of a problem to solve. And all of the optioneering and evolutionary solvers and these kinds of heuristics have been in use in engineering for ages. And it's great for very targeted tasks. So you have a very specific problem, and you don't know the best solution, or at any event, arriving at an ideal solution for you is going to take a while.
But
so you
how
basically
to measure the correct solution. How to quantify it numerically in some way.
It is very quantifiable. That's what makes engineering stuff work really well. Or I can give a personal example. Years ago now, this was in 2010, working on building and doing detailing work, basically orienting steel that would not clash and would be using as little material as possible and would work structurally. I just had in
a very complex building.
In a very complex
building. Which is
the Louisiana
Museum and Sports Hall of Fame.
Yep.
To solve that geometry problem would have been very painful for someone.
Absolutely. And it was really targeted for these moments where there was very little space and had to get the steel in there. And for me to spin the sliders around and to find an ideal solution would have been a pain in the butt. But the problem was so well defined. It was so clear what the boundaries of the problem were. And it was perfect for that. Those kinds of search heuristics are amazing when the problem is incredibly well defined. When you have these really open-ended problems, and going back, generative design, it's essentially, at its core, those are the first things Dreamcatcher and this they're doing, essentially like a form of evolutionary solvers. It's basically heuristic searches, as you said, optioneering, these kind of really well-established terms for sort of identifying a variety of options and then exploring them systematically, either through brute force or through some kind of search heuristic.
So what makes that process, because I think your terminology paper is in many ways a bit of a challenge to the use of the term generative in this context. What makes the current application, or what we're defining as generative design today, not generative?
Well, you said earlier, I think it is a marketing thing. So I think that the idea was, well, how can we take these optioneering search heuristics and give it a term? And then they said, well, we generate a lot of options, so we'll call it generative design.
So you're seeing it as a very literal application of the term generative, when generative means something very different in your view.
Yeah, and also historically. So
explain that a little bit. Explain what historically you've kind of observed or or researched generative design or generative, the term generative in the art context to be?
Well, there's, I mean, an old colleague of mine at CETA, Jakob Rieber, he wrote his PhD on generative design. So he would be a great person to talk to about it.
We'll fly him over.
Yeah, get him over here.
In a future podcast.
It's a super dude. But so a lot of his research actually led him to the art world, where generative art is a thing that really was happening in the 90s, and essentially, the term was driven by people that were researching it there, that were engaged in like active academic research for generative art. And you can see I've got a definition here.
You've got the terminology paper. So what is the definition of generative?
2003, Galanter says that generative art refers to any art practice where the artist uses a system, such as a set of natural language rules, a computer program, basically a procedural approach to create. It's basically set in motion with some degree of autonomy, contributing to or resulting in a completed work of art. So it's basically you turn an algorithm loose and it has a semi-autonomous approach, and it comes to a result, and then that's the result. It's very different from optioneering, which is where you create a ton of things and then you pick one. And then you also have people like Hod Lipson, who's at Cornell. He's a really brilliant roboticist who is basically evolving robots that could move. So essentially using L systems to do this stuff. And for them, 2001, generative is basically something that is a generative system, particularly as it pertains to design modeling. He says that they are defined according to their ability to deploy algorithmic transformations and reuse embedded subsystems. So basically, it's like closer to a biological growth algorithm, So it's recursive. It's something that's building on top of itself, and you turn it loose. You basically, it has this kind of autonomy. And you can see it, and there's some design that does it, and a bunch of the projects that we worked on, over at CETA, like a lot of these research shops that make the funky pavilions.
Right.
They're doing things where it's like one element grows and then something else grows on top of it, and then it relies on precedent information within the system to create new things, which is really a very different diagram, and that's really well established.
Right.
So this kind of like it's like a co-opting of the term. Which is what, I mean, in some ways it's a term, so it's a term, but it is kind of...
The mental picture that I get as you're talking about it is like if some kind of additive process for like 3D printing or something was also reading what it had created. So it creates something and it reads it, and then it creates something again using that same process, and it keeps repeating. So
exactly.
It's like the way that, biological... Like the way a tree grows,
there's like a sensing involved in it. There's a production and then a sensing and then a reaction. And then cyberneticists really talk about this kind of thing as well. And that's exactly it. It's like you have a system that has sensors and effectors and actuators, and it basically adapts and evolves and reacts to changeable conditions. It's a really different diagram than what we see in optioneering. I mean, it's just
optioneering, and then what would you then make, or how would you classify the genetic algorithm, or the sort of the multi-objective use of things like genetic algorithms in the back to sort of evolve a system in the search? So it's sort of using evolutionary solving. Does any of that have a generative quality to it, in your view?
Not really. No. Right. I mean, it's the same. It's optioneering. There are search heuristics.
Yep.
I mean, I think that it's very similar to brute force. It's smarter than brute force in the sense that it is trying to find an ideal solution, according to certain metrics. The constraint-based kind of approach. I think it's just a function of a term that took on a life of its own because of...
It sounded cool.
Marketing.
It kind of sounded cool, right? And in some ways, if I put my marketing hat on, which I do quite a bit of marketing, and even this podcast is a bit of marketing.
It is.
if it's good. If it's good. But, you know, as a marketing term, I also, the problem I have, I think even more than perhaps a misapplication of terminology, which, you know, you can get into really rich and deep semantic arguments about these terms. And I've certainly misused my fair share of terms in my day when describing certain processes, I'm sure. I think what's perhaps more disconcerting is the overhyped and overpromising nature that results from the narrative around generative design, and this idea that the computer is in a position where it's making decisions, which isn't, you know, in the context of AI and you know, where we see a lot of that science and stuff going, isn't necessarily out of the question. I don't think designers are immune from automation disrupting their work and disrupting this ability to be creative. I think we can see examples of this. But there is quite a bit of overpromising, and I think this idea that, oh, you know, as a designer, you're able to just input your criteria. Yeah. And this whether we call it a search algorithm, an optioneering algorithm, or genetic algorithm, evolutionary solver, or just generative design, as it's been kind of given, to me does a discredit and misleads folks in terms of how much work actually goes into creating one that can work. Because you're not just simply putting things in and letting this computer search a space. You actually have to design the algorithm. Like, you know, when using Project Fractal, you needed an entire Dynamo definition that was really well made and had inbuilt the assumptions that would have made the search reliable and the results reliable. And same with Grasshopper and the use of Galapagos or Octopus.
Nothing's taking the complexity away from that. And that's even for really simple problems.
Really simple things. Like,
you know,
like you need a graph to tell or, you know, to feed into one of these things, to do something as simple as box volume optimization, a simple box where you're looking for some kind of optimum that maybe creates the equilibrium of the surface area to the inside volume. Like really simple, almost like, you know, calculus 101 problems, you know, require this type of setup. And it's kind of like, oh, well, you know, with generative design, as if it's a product.
Right. As if it's a thing, as if it's any one thing.
With generative design, you're going to be able to do all of these things in the computer. You're basically going to be a selector. You're going to find, you're going to like choose the options the program gives you. Like, no, actually, you need to know how to design algorithms, which
they're finicky, they're fragile. You know, if you
and,
say
and architects are not very good at this yet.
Yeah.
I mean, and again, this goes back to that initial point that led into this discussion. People are still, like, in the world of architecture, construction, people are still skeptical of BIM,
right,
as an idea, and we see it day in, day out, the struggle that firms have getting their staff up to speed, skilled up to use these tools out in just some Grasshopper 101 and have it be applied in a very productive way, or Dynamo 101, and this idea that, oh, we got to get on this generative design thing. That's great, but there's all of this other stuff you need to do before you get to the point where you're even going to be close to productive with this, and it's a huge gap that's being left out of the conversation.
And there's an art form to setting one up that is not over or under constraint.
Yes.
If you over constrain it, it's only applicable to this one tiny problem that you have picked out that you need right now, and you'll never be able to apply it again. So you've spent double the time for what benefit? Sometimes it's hard to tell. But if you under constrain it, you get garbage back out because you haven't given it enough constraints to find an optimum.
And like you said, I mean, even just authoring those constraints is really difficult. Like it's a non-trivial problem to set it up. I mean, if any generalized approach is probably going to be overly simplistic and isn't really going to give meaningful output. It's the same thing with parametric models in general. I mean, it is a real problem with them. I mean, they are really fragile. I mean, our friend Daniel Davis has written about this extensively, and like, RMIT had a whole sort of research project around the fragility, the inflexibility of the flexible model.
Right.
Parametric models are supposed to introduce flexibility. They're supposed to become more fluid, but the reality is that they break really easily. And if you want to add a constraint later on, I mean, you got to go back at the graph, you got to figure out where to put it in. A lot of times it just makes sense to actually start again. And obviously, I mean, there's still tons of value in it, but it's non-trivial. It's not easy. So yeah, I mean, the distance that we are right now from a sort of generalized optioneering, evolutionary solver deployed approach. If you want to call it generative design, you can, I guess.
Yeah.
It seems like we're really far away from it really solving the kind of general problems that people are actually really good at solving. Like, you get a good designer, and a good designer is going to say, no, you do it like this, and people are going to understand it. And there's a level of parallel thinking and intuition that designers are really good at. Like that's their job.
The example I can kind of point to that comes up a lot. People come to us with this idea all the time, especially if they just went to a seminar on generative design or attended a conference where they may have heard of this for the first time, or maybe they've been looking at it for a while but haven't quite known how to apply it. They're like, oh, well, this seems like a really good problem for space planning. And on the surface, it seems that way, right? Because it's, okay, we have quantifiable components that need to come together in a certain way using a set of rules to describe a building and create a layout for us. And there might be all of these possible layouts.
It's just a series of rectangles.
Right, a series of rectangles that need to be kind of arranged in a certain way. But I'll say this every single time: a planner is going to be able to solve that problem better than an algorithm that you can design and try to do it from the ground up.
Probably faster.
And the reason for that is that on the surface it seems really easy to kind of encode in the form of an algorithm, but all of the micro decisions, all the edge decisions that a planner makes about how a space gets arranged and laid out, and how it relates to other spaces. If you really start going into those decision gates, it becomes a really hard problem to model. And then so it's for me, it's always been about, okay, well, let's take a step back and look at the problem of space planning, the problem of generative space planning, and think about it in the context, well, are there applications of the tools that can just help the planner make better decisions faster, or draw the solution that they have in their minds a bit faster? And so it's a very kind of different philosophy.
I totally like much more local problems, like a tactic rather than a strategy. The tactic and the strategy are basically just it's the same spectrum, it's just different scopes of vision. So the strategy is something that's really long term, and the tactic is something that you see more close by. So you solve the problem tactically, you're just addressing the more local issue. And I think this is a perfect example for where that kind of thinking and understanding that these tools are really good, like for the detailing problem that I had. It's a really local problem, very, very tactical, right here, right now, right in front of you, well-defined, very clear. So you apply it there selectively, but the strategy, the overarching way of implementing it is something that a designer is still going to be a lot better at. And over time, maybe we find ways as we get more advanced to stretch that range of vision that these tools can really be applicable to. But in the short term, I think much more effective would be feedback tools that the designer could use to understand what they're doing. So instead of it solving the problem, more like adjacency solving. So, okay, well, how have I done this? All right, well, let me do a space syntax analysis of this and see what kind of adjacencies. Yeah, so you have like analytical feedback as you're going as a designer. So you can say, oh, okay, well, I have this much space left to plan for this program, et cetera. I know how many rooms I need and things like DeRofus, how you integrate all these other ways of how space planners work with sort of apportioning out the requirements. Having better feedback is something that I think would be leagues more useful than something that basically said, yeah, this is where the gym should go. I mean, it's like,
it's
well,
stable.
yeah.
It's more stable over time, which is, at least for us, the reason that we probably all got out of doing, the the nodes and wires and actually, typing code because it's more stable and it can be reused.
It's more generalizable.
Yeah.
I mean, we kind of talked about the marketing side of it. I think the marketing has done its job in kind of really affecting the way that we talk about certain things, and talking about generative design. If we go to the Wikipedia page for generative art, you have a very rich page detailing where this concept of generative art came from, the history of the term, the how it's positioned relative to other trends in the art world. And then you have these references. These references on the Wikipedia page just take you to paper to paper to paper. These actually well-researched uses of algorithms for the purposes of art.
There's tons of precedent in academia for generative art.
And then you go to the Generative Design Wikipedia page. You get 2 paragraphs, which has references. All the references just go to blogs. And I would say about 80% of the reference material takes you to an Autodesk website, right? So they've done an excellent job branding this. I'm kind of, in some ways, I'm in a bit of an awe of how their marketing machine has actually taken us to the point where now we use the term generative design in a very kind of, if you look on Twitter, a very kind of common and a common dialogue about these things. Oh yeah, generative this, to the point where I think it's almost become funny in the context of like papers and presentations now. I saw a conference listing for presentations that were going to be coming out. It's going to be coming out soon. They're going to have an event soon. And every one of the titles was, something generative design.
Yeah.
It almost felt suspicious to me. I was reading the descriptions. I'm like, oh, that sounds like an interesting problem with generative design. It's kind of become the new blockchain, where blockchain has been so overhyped and like across the technology industry, where to the point where there were even a couple of instances where companies that had nothing to do with blockchain and the open ledger concept simply took their, public companies, they took the term blockchain and appended it to their name, and their stock value went up. Because blockchain, we got to get in on that. Let's, their value is all of a sudden higher, and that to me is concerning as a trend. Again, going back to perhaps the overhype, the overpromising, when everything you just described is very reasonable when it comes to where we should be going. In the near term, at least, figuring out how these things are positioned.
It's odd.
It's very odd.
It's a pity. The thing that's a pity about it is that, so many of these tools are great tools. So much of the I think the first generative design was this topology optimization approach.
Right.
Is basically like evolving good structures. And it's like really pretty great. Project and the Galapagos and like Octopus, the multi-objective plugin for Grasshopper, even in Refinery too, like, these tools, they work. You can solve problems with them, it's just such a pity, as you're saying, like
right.
that it's all being hyped up and promised like that it's going to be this kind of new panacea for solving your issues for you in a way, and it's like it's a lot trickier than that. And what'll be a shame is that if these tools get a backlash against them because they fail on this really high bar, rather than thinking about ways to strategically deploy them where they could be really effective.
Right.
Does it devalue the whole concept of using computational design in some ways if the hype far exceeds the reality?
Well, totally. If we look at the the Gartner hype cycle, the next stage of the hype cycle is the trough of disillusionment, and that happens, and then technology just kind of falls off and dies if it doesn't somehow like come out of that or circumvent it in some way and get to a place where people are productive with it. And I think people are productive with these tools. There's no doubt about it. But the expectations are so high that people, they want the space planning generator But if you then come back, well, it's actually what I thought was more interesting is figuring out how we could deploy this to help populate a few desks in a quick manner. But then we're like, well, that doesn't solve the big space planning problem. And then just I guess we'll just keep.
I guess we won't do anything.
I guess we'll just keep drawing, and I guess it's just as fast for someone to just drop desks in.
Yeah. And what's funny too is that even on that hype cycle, it's literally just a term, because the technology that it's built on, it's been around for a while.
Right.
It's
been around for a long time.
Yeah. All these heuristic approaches have been around forever.
Which is why I'm I remember giving a class on Galapagos when that came out. That's really a technology that I got really interested in, genetic algorithms and the sort of optimization routines. And again, I'm a designer. I'm not a coder or a computer scientist by discipline. I think the same goes for all of us. And it got me into this space, and I was able to start to look for ways to deploy this, and I taught courses on genetic algorithms and evolutionary solvers to folks at USC, and then it kind of trailed off. I'm like, okay, well, that's cool. On to the next thing. 8 years later, generative design is the new thing, and I'm like, oh, what's that? Is that just an evolutionary solver? Wait a minute. The thing that kind of trailed off and was really popular for a while is now the thing. I don't want to sound like a is that kind of a classic? I was into that band before they hit the mainstream.
No, I think it's just puzzlement. I think it's fair puzzlement,
and it's branded under a new thing that you're like, wait a minute, that's not quite. It's not quite aligning. But I guess we can kind of wrap up. I think the idea here is that there is a lot of hype around this concept. The term isn't going away.
It's not going away. It's here now.
In some way, I think you, David, I hate to tell you, but you've lost the terminology argument.
I know.
People are going to use generative design.
The mob has spoken.
The mob has spoken, and it's going to be used until we run that marketing ship into the ground, and it henceforth is about an implementation of an evolutionary solver and a genetic algorithm. So we've lost that one. But I think what we haven't lost, and I think hopefully what we can really put our time and attention to, is how these concepts can play a productive role in the life of a designer, and cut past the hype to where we can, as a community, deliver value with them, and not over fetishize the concept to the point where generating 1,000 options is the end goal. What we want are better buildings at the end. We want better performing buildings, and we want more efficient to produce buildings. We want these sort of performance objectives, and I think the sort of the fashion of being able to say, well, this solution came from 1,000 permutations of this algorithm. So what? It's kind of like it was very fashionable for a while to slap your Grasshopper algorithm on your presentation board at school, right? Mm-hmm. As if it somehow justified the result. Because it came from an algorithm, that all of a sudden validates all of my design assumptions. That's not the case, and I don't think we can say the same. I think we can say the same about this the generative design conversation. Just because you create 1,000 options of something doesn't mean it's better. You have to prove why it's better.
I totally agree.
And not everybody that's in the AEC industry needs to be able to or willing to use these tools for them to be useful. I mean,
right.
We need to find ways that we can support the people that aren't interested in being experts in all of these things. And I think that's kind of what we're all about.
Yeah, absolutely. It's to get a broader adoption. The more generalized approaches are going to be for much simpler problems at this point, and especially going against all of the constraints about skepticism surrounding computation that persist, and that will persist for years and years to come. It's time to take a smaller bite. I think
Take a smaller bite.
Yeah.
Take a smaller bite.